All right, I'm just going to talk about modulus argument form and just a relationship between a complex number and how you can write it in terms of the angle at 0 and its modulus, which is the distance that the complex number is from 0, 0. I also want to just relate this to vectors, because we've got the complex number z, but the vector there is actually, like, say that was a and o, so the vector AO is z minus 0. And this just really closely relates to vectors. Okay, so if you have a complex number and that was x and that was y, and that's theta there, then that means that the complex number is z equals x plus iy. Now, if you look at that triangle, the right angle triangle there, cos theta is x over r. And r is the distance that z is from 0. So x can be written as r cos theta, and also sine theta is y over r, so y can be written as r sine theta. When you put this into your rule up here, z plus x plus iy, then you can go x cos theta plus I r sine theta, and you can just factorize out the r, and you get cos theta plus I sine theta. Now, just a shorter way to write this, you can also write this as I cis theta. And the C comes from the cos, the I from the I there, and the S. So that's where that cis comes out. And it just gives you a quicker way of writing it. I just want to point out that this actually relates to the magnitude of that vector ZO, and also to its direction, which is theta. A couple of other things when you're looking at this here is basically that the R, we call that the modulus. And the modulus is just the distance that Z is from 0. Now, you can also write it as mod Z. So mod Z looks like the absolute value, because the absolute value just means the distance that value is from 0. So if you're looking at this triangle here, and you have Z there, and that's X and that's Y, to get what the R is, by Pythagoras, it's actually just X squared plus Y squared. So mod Z is the same as X squared plus Y squared. And to get the angle, because that's theta there, we can just say tan theta equals Y over X, because it's opposite on adjacent. So therefore theta will be tan the minus 1 of Y over X. So once you have something into mod arg form, you can do so much more with it, because it's in terms of trigonometry. And it also relates so very closely to vector. The angle theta is like the direction of the vector, and the modulus is the magnitude of your vector. So we're just going to put these into mod arg form. Okay, so to put these into mod arg form, first of all, the modulus of 2 plus I will just be the square root of 2 squared plus 2 squared, which is root 8 or 2 root 2. And it's really important actually to plot the point, because 2 plus 2i can be plotted on the Argand diagram as 2, 2, which is 2 across and 2 up. And when you do that, that means it's in quadrant 1. So that means when you're doing tan theta is 2 on 2, which is 1. So theta is tan the minus 1 of 1, which is just 45, or pi on 4. So that means that 2 plus 2i can be written as 2 root 2 cis pi on 4 in mod arg form. Now I just want you just to take a look at something. If we put 2 plus 2i, if I went back the other way, that would be cos 45 plus I sine 45. And if you look at that, that's 2 root 2. Cos 45 is 1 on root 2. Sine 45 is 1 on root 2. When you expand this out, so when you expand this, you get 2 root 2 times 1 on root 2 plus 2 root 2 times I on 1 on root 2. And the root 2's will go out. And so you get 2 plus 2i. So that takes you back to what you originally started with. Okay, so putting this into mod arg form, first of all, the modulus of 3 minus 3i. Let's do that part. Okay, so let's just have a look at part B, which is 3 minus 3i. So which quadrant? So 3 minus 3 be in the fourth quadrant. So tan theta would be minus 3 on 3, which is minus 1. If you're in the fourth quadrant, tan is negative. If you just want the acute angle, it'll just be tan the minus 1. You don't need the negative. So it'd be 45 or pi on 4. The negative just places us in that quadrant. In that quadrant, the angle would be minus pi on 4. Because basically, when you're doing things in mod arg form, the angle is going to be theta, then it will be pi minus theta, and minus pi minus theta. And then looking at the modulus, so modulus 3 minus 3i will equal the square root of 9 plus 9, which is root 18, which is going to be 3 root 2, because it's basically root 9 times root 2, which is 3 root 2. So then putting that into mod arg form, that would be 3 root 2 cis pi, negative pi on 4. And that's what it is in mod arg form. Okay, so let's look at C. Okay, so looking at C, minus root 3 plus I. So basically which quadrant? So it's minus root 3, 1. So negative x plus y. So it's in that quadrant. So tan theta would be 1 on minus root 3. So the acute angle would be tan the minus 1 on root 3. That's basically 30, which is pi on 6. In that quadrant, it will be pi minus pi on 6, which is 6 pi on 6 minus pi on 6, so it's 5 pi on 6. And the modulus of minus root 3 plus I is root 3 squared plus 1 squared, which is root 4 or 2. So that's 2 cis 5 pi on 6. Okay, all right, so the next one, so that's D, so it's minus 4 root 3 I. So tan theta is minus 4 root 3 on minus 4, which is just root 3. Negative x and negative y would be in that quadrant. So it's going to be minus pi minus theta. So the acute angle is tan the minus 1 of root 3, which is 60 or pi on 6. So it's minus pi on 6, which will be times 6, so it'll be minus 5 pi on 6. And the modulus of minus 4 root 3 would be the square root of 16 plus 16 times 3, which is root 64, which will just give you 8. So it's going to be 8 cis minus 5 pi on 6 in mod arg form. So just changing things back to Cartesian form, we'll just look at 2 of them. So let's go cis minus pi on 3 and 4 cis 3 pi on 4. Okay, so when we're figuring this out, that's going to be 3 cos. Now, minus pi on 4 is the same as minus 60. So it's I sine minus 60, which is 3. Now, cos of minus 60, so it's going to be in that quadrant, would be positive cos of 60, which is cos a half. So if we look at this as 60, 30, 1, 2, root 3, so it'll be the same as cos a half, and then minus I sine, that'll be root 3 on 2. You could also do that as 300 degrees, or do the same thing, because 360 minus the 60 will give you 300 in the positive direction. Okay, so this one here, this is 4 cis 135. So 135 is just there. So it's 4 cos. Now 135 in that quadrant for cos would be minus 45 plus I sine. Sine will be positive because it's a 45 angle and cos is negative in that quadrant and sine is positive. So it's minus 1 on root 2 plus I sine 1, plus I 1 on root 2. So 4 on root 2 minus plus I 4 on root 2. Rationalise the root 2. And you'll end up with minus 4 root 2 on 2 plus I 4 root 2 on 2, which gives you minus 2 root 2 plus I 2 root 2 as your answer.